Okay, so based on what we've done so far, if you have x squared equals negative 1, what should we do next to solve for x? Square root both sides, right? If you did, you would get x equals plus or minus the square root of negative 1. What have you learned about the square root of a negative? Not possible until today, as far as I know. I know a few of you have been exposed to the imaginary numbers in the past for whatever reason. Today we're going to introduce imaginary numbers. They're called complex numbers is where we're headed. Now, for a variety of reasons, and I am no expert on the application of the imaginary unit. I can tell you for sure that they utilize it in electronics, but in fact, we were talking about it today at lunch. We're all pretty limited on this. Because we have troubles with square roots of negatives, what they decided to do is they said, well, let's just say the square root of negative 1 is going to be called I. I is called the imaginary unit. It's a variable, but in our case it works like pi. Pi is a variable, but everybody knows that pi stands for the ratio of circumference to diameter, and it's a pretty constant number, although it's irrational. It's constant. It doesn't change. I is the same way. It stands for the square root of negative 1. So if that's true, x equals plus or minus the square root of negative 1 would simplify to what? No, close. Plus or minus I. So x equals plus or minus I, where I is the imaginary unit. The square root of negative 1 is the imaginary unit I. And if that's true, if we squared both sides, if we square I, we would get I squared. If you square the square root of negative 1, you get negative 1. I is the square root of negative 1. Therefore, I squared is equal to negative 1. And it's going to be important that you have a really good grasp of how I functions and how I simplifies. That's going to be important to us. So these are the book notes on this. I is the square root of negative 1. I squared equals negative 1. Okay? So now, if we look at equations, of which this one you're going to say, we can now simplify. Prior to today, you would say there's no solution. Or if you were taught really well early on, you would say there's no real root or no real solution. What am I going to do to solve this? Okay, just like we've been doing, just like on the warm-up we did a moment ago, same drill, so we're going to be at negative 90. Then what? Absolutely, 5 by 2, so it would be at negative 45, right? At this point, most of you learned, hey, no real roots, no real solutions, we're done. But now we want you to take it a little bit further. Oops. If we square root both sides, x is going to equal, technically, what should I put here? Plus or minus the square root, negative 45. Where the trouble comes is that it's a negative under the radical, and we've always said, can't do it. Now we can do it. Good guys and bad guys. What's the good guy factor of 45? 9. Bad guy factor would be 5, and because it's a square root of a negative, we can treat this as the square root of negative 1. And believe me, I am overdoing right here. There's no need for you to write all this down. Okay? There's no need for that. So I wouldn't expect you to do it, and I'm not expecting me, don't expect me to do it. We would bypass this step altogether. And we would simply, I would have written the square root of 9, square root of 5, and then I would have just put the I out here. Then I would go to x equals plus or minus 3 root 5, Make sure this I is away from that radical. We get going and we're cranking through these problems, and sometimes we write 3 root 5I like this. And how does that look? Like the I is under the radical, and that's not where you want it. So some people will say, okay, well, let's put the I over here. Put it in front of the radical, and I'm okay with you doing that under those circumstances. It's not necessary, but if I see something like this, I am going to circle this and put a -1 because I won't be able to tell. And that's just not what you should be doing. You should be writing this down right now. You're in this class. You just got back a quiz which was all about the details. This is a detail where you lose a point. Make sure that I is not under the radical. Or put it in front of the radical. But if it's a mystery, we'll mark you down. Be really conscious of the details. Question on that? Yep.
So why is the I under the radical?
Because the square root of -1 is I, not root I, it's I. So, and that's why I write this out the first time. When you have a negative, you have a square root of -1. Technically, the square root of -1 is I, not root I. So we want it out of the radical. Okay, try this one. So you run a pattern of 4. I to the first is I to the second is -1. I to the third is -I, and I to the fourth is 1. To find out anything else, you divide the power by 4. 21 divided by 4 is 5 with a remainder of 1. The remainder is the power on the I, either I to the first, I to the second, I to the third. And that tells you what the equivalent value is.
How did you get 36?
36. 9 times 4 is 36. We're doing line division here. 4 goes into 37 9 times.
Okay.
9 times 4 is 36. Draw a line, subtract. You get 11. 4 goes into 11 twice. 2 times 4 is 8. Subtract. Remember doing this in 5th grade?
Yeah.
And you haven't done it since, right? Seriously, we don't do this anymore. My wife had to do line division the other day. She couldn't do it. I need a calculator. Bring me the calculator. Can't be done.
So no matter what the power is on I, if you divide it by 4 3 times, it's always 4. Then what you get the remainder?
Correct. It's 4 because this is a pattern of 4. On the first, second, third, fourth, then we repeat. Why do we repeat? Because we have a group of 4, and what is I to the fourth equal to? 1. So we take 4 of the i's away, what's left? There's an I to the first. We take 4 of the i's away, what's left? I to the second. Here, you take 92 groups of 4. You take 368 i's away, because that's what this is. I times I times I times I, 371 times, right? Take 368 of them away, because that makes 1. And you're left with 3 i's, I to the third, which is -I. Okay? And it keeps cycling that pattern of 4.
Wait, what is it? There's no remainder.
Well, if there's no remainder, it went in evenly, right?
Oh.
So you had all I to the fourth, your answer is 1. We love that.
So wait, what do you do with the 0.75 though?
The remainder is 3. That's I to the third.
So how do you know?
I memorized it.
So
So I'm telling you so you can memorize.
So what does 3.75 represent?
Who cares what it represents?
Well, I just don't get how you're getting.
Okay, so then we want to do remainder of 3, right? So I to the 19th. We take 19 and divide it by 4. How many times does 4 go into 19?
4.75.
No, I want to know how many? 4 times. 16, what's the remainder? When you subtract, what's the remainder?
3.
3. What do you do with this 3 in 5th grade? Put it over the 4. So you get 4 and 3/4. What's 3 divided by 4 equal? That's where the 0.75 comes from. What's the 4 represent? It represents 4 groups of I to the 4th. There's 4 I to the 4ths. What else do we have? We have 3 i's left over. What's this equal to?
1.
In this one,
1.
in this one, in this one. When you multiply them all together, times I to the 3rd is I to the, look up here.
Negative.
Look up here. 1 times 1 times 1 times 1 times I to the 3rd is
Negative.
I to the,
4. 3rd.
well, that's why I want you to listen to what I'm asking. You're not listening to what I'm asking. You're trying to answer my next question. You're precognitive. 1 times 1 times 1 times 1 times I to the 3rd is equal to I to the 3rd. But what is I to the 3rd? Negative I. Okay? We don't care about the 4. We don't care about the 92. Because all that is 92 ones. When you multiply them together, it's 1. The remainder is our key. What's the remainder? It's 3. That means this is equal to I to the 3rd or negative I. Negative I. So on the one right here, this answer is negative I.
Could you just go straight from 6 after
One more time?
Could you just go straight from 6 after remainders to the I to the 3rd?
You could go right to this. I mean, if you want to put I to the 3rd and then do negative I, I'm fine with that. But I just said, look, the remainder down here was a 3. The answer is negative I. I know I to the 3rd is negative I, I'm just going to the answer. Okay? No need to do anything else. Is everybody okay with that? Thought we still might have another example later. Okay? All right. Second part of today has to do with numbers that have the imaginary unit as part of the number. They're called complex numbers, not because they're difficult, they're just complex numbers. Now, all numbers can be written as a complex number. Whether it's real, imaginary, we can write them as complex numbers. In a complex number, A and B are real numbers. When you write A plus or minus BI, A and B have to be real numbers. I is the imaginary unit. Now, if B is equal to 0, this whole green part is gone. And what kind of a number do we get? A real number. So if B is 0, we wouldn't write 7 plus 0i. We would just write the number 7. And you would get a real number. Okay? So if B is equal to 0, you're going to get A plus BI as a real number. You're not even going to think about it. It's ridiculous. You would have the number 8. You don't say 8 plus 0i. Oh, it's a real number. It's just 8. It's real. If B does not equal 0, then A plus BI has to be an imaginary number. BI makes it imaginary. And if A is 0 and you just have BI or negative BI, you get what we call a purely imaginary component, a purely imaginary number, like 6i, negative 1/2 I, negative 0.27i. That's just a purely imaginary number. The reason why I'm stressing A0 or A0, B0, that kind of stuff, is because all numbers can be written as a complex number. And I'm not telling you it needs to be, I'm just saying it can be. Now, we, in the past, here at this school, have not taught some of the stuff we're teaching now. And it's easy stuff with these complex numbers in Algebra 2. We want you to be looking at this stuff and saying, this is easy. If I'm going to graph a complex number, that's easy. I can do that. It's on the STAR test. They're free points. So we want you to be able to get those free points. Okay? It is imperative that if you have a complex number, however, it must be written in the form of a plus bi, no exception. It can't be 3i minus 7. That's not acceptable. Okay? It has to be minus 7 plus 3i. Can I do what?
You go back.
The last side just is a plus bi. I'm waiting. I'm waiting for a green light here.
Alright, here you go. Green.
Green?
Green.
Good? So what do you say when you want them to do their thing? What do you yell at those people? What word do you use? Many words? And they mean different things? Well, what if you're just cruising and you just want them to do what they're supposed to be doing? Just do your thing. They're all technique is good, but you're trying to do you're wanting to do their thing. It's always perfect. Come on. So what do you say? When you're in a race, what do you say? But you're not doing occasions? I want to know. I don't know these things. You're a resource for me now. When I'm watching this on TV, I know what they're... You beeping, 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 beeping. Is that what we're doing?
No.
Not normally. Okay, so there's nothing you say when you want them all to do their thing at the same time?
Yeah, there is.
What do you say?
Are you trying to get them timing?
Yes.
So you don't even know what catch is?
No, of course I don't.
I don't. You're not gonna get.
I want to hear you yelling it out.
I'm not gonna yell it out.
Come on!
Say it.
No.
Oh, man.
Bro.
You don't have to do it today, but you're going to have to do it.
I've never.
And you're going to have to do 10 of them in a row. Okay, I'm just telling you.
You say actually
All right. This slide right here is one of the ones where I look at it and I go, I can't even believe I'm making this to show you how to add these things together. It's so beneath you for me to do this. It's so obvious. You all would know what to do without my help. You don't need this to tell you how to add complex numbers. I am totally serious. There is no reason for me to do this. If I just showed you this, right? If I put this slide on here, okay? Watch. Go ahead and simplify that. Do it right now. Take you 2 seconds to do this. It'll take you longer to write the problem down than the answer. And almost everybody in the room is going to do it correctly. 3 plus 4i, complex number, right? 2 plus 7i, complex number. When you add them, what do we get?
11i.
Rocket science, huh? What did you really do that you learned 4 classes ago? Someone said it. Combined like terms. Rocket science, right? But no, these are complex numbers. We better explain this to you. Like you're morons, right? Look at this. It's telling you that you're supposed to add the real parts, A and C, boys and girls, and then add the imaginary parts, B plus D, and then multiply it by I. Do you really need this? Seriously, I'm embarrassed for myself. Okay? You guys are so good, there's no reason why we can't just throw this at you. What is I? Imaginary unit. Square root of -1, but really, if you have to give me a one-word answer to this question, what is I? One word, it's a variable. It's a special variable, but it's a variable. All right? Try this one. Oh, I think we have special stuff on here. Oh, I had it on the last one too. Wait, somewhere down here. Look at that. I could have done the magic. You missed it. Here, let me do it for you again because that was so cool. We're going to add those two together and try this one. I know. Little things that kind of entertain me today. Focus. Now, there are people in here who got it wrong. There are people in here on their paper right now that have -1 minus 2i. Okay? You're not supposed to. I was letting you be anonymous. You don't just take out the eraser and start. I mean, now everybody knows. Gee, let's see who had that. 2 minus 3, -1. -7i plus 5i minus 2i, right? That seems to make good sense. Except what you're doing here, let's see if it's in here. There's got to be one here somewhere. There it is. You're making the most commonly made mistake in algebra. Not in America, because I think they do this other places besides America. You need to distribute the negative. Okay? Are you seeing that? You sure? So when we combine like terms now, somewhere in here we got an answer, you should get -1 minus 12i. This is what we really want. Hate it when that happens. Everybody okay with this? Don't worry, you're not alone. The other people just were better at handling that. Try A and try B. Try both of those. Look. Let's go green on this one. First one, we're adding. Adding's way easier. Less apt to have that most commonly made mistake in algebra. What do we get for A? Someone volunteer. Give me a volunteer. 20 minus 8i. Are you sure?
Oh, whoops.
I'll take the whoops as no, I'm not sure.
I didn't write down -8.
That's overrated to write it all down. What is it? 4 minus 8i. Yeah? Bring it. -9. Anything else? Minus 18i? Plus 0, we don't need to do that. What about the 18i? Did anybody have 18i? No. No, because the i's cancel, so you get a real number. That's good. Whoa. Stop. All right. So this one, 35 minus 13 minus 4i plus I. Now the 35 minus 13 becomes your 22 minus 3i. Everybody see that? What do you want it to be?
Okay, to read.
I'm open to debate. I make mistakes all the time. You gotta catch me on those. I distributed -1. Great, that's why we call it the most commonly made mistake in algebra. It's not by coincidence. There are a lot of those, hence the name most commonly made mistake in algebra. That is, it's the most commonly made mistake in algebra. How much more do I give you on that? Alright? Uh-oh. So now, those of you who try to skip steps, you're going to get killed on this one. So we're multiplying. So it's no different than if, excuse me, if this were an X, but it's an I. So we still do the monkey method. Or whatever method you're going to use. Huh? The monkey method is the same as FOIL or whatever you do. You get 12. You get minus 10i squared. You have 8i, and negative 15i is minus 7i. It's called the monkey method because it looks kind of like a monkey face in here. It's not the pretzel method.
I see the pretzel one with the monkey.
Yeah, I don't see
That's okay, you don't have to. I squared, what's it equal? Doesn't not. I squared, what's it equal? -1. 12 minus 7i minus 10 times -1. And again, I'm showing you way more than you need. What?
22 minus 7.
Where did I get minus 7i? 2i times 4 is 8i. 3 times -15. What are you asking me? You just messing with me?
No.
You're screwing up my rhythm. My coxswain over here is going to start changing my form over here.
I'm giving you the answers.
Catch, pull, throw, finish.
Losing.
Now it's a mess. I'm getting out of here. What? I'm using what I call the monkey method. You do it any way you want. I'm not, but
Where are you getting 7i?
okay. Use it. That'd be awesome. Hopefully you got this. And then I squared became -1. -10 times -1 is positive 10.
That's what I was saying. The answer.
Messing up my form.
179.
Wait, I wasn't paying attention. Hang on. You were. What did you get in the middle? Okay, this is -15i right here, right? This is positive 8i, right? A -15 and a positive 8 is -7 when you combine them, correct? That's why I wrote that -7i. Didn't you just say, where'd you get the 7i?
Yeah.
And wasn't I explaining that? And when I got to the end, you should have said, oh, but no, it was like, why are you telling me all this? You're like 10 seconds on. I started it, and 10 seconds went by, and we don't know why we're doing this. Oh, okay, we're good. Okay, this one should be easier. But some of you are going to write the answer wrong because of the L factor. Late. All right, so again, those of you who are getting out the eraser again, and you put -40i plus 45i squared, -40i minus 45, and you left it like that, that's not an acceptable answer. You cannot write a complex number like this. You have to write it in the form of a plus bi. It's not negotiable. Okay? So we have to make sure our answers are in the correct form. Try this one. Look, see if we can do the monkey method here. Now, how much you show is up to you. 32 negative 14i squared. 8i and negative 56i is negative 48i. What's I squared equal? Negative 1. So negative 14 times negative 1 will be a plus 14. So 46 minus 48i. The end. Yes, sir.
So negative 49 squared. Since it's 2i, should this be like 2 plus I minus 2?
We're multiplying now.
Negative 7.
What's x times x? If they were x's, x times x. I times I squared.
Yeah, but I'm saying like,
Maybe I misheard you. Go ahead.
what about the 7? So you have the 14 by half and multiply it to 7.
Right.
And you have the I squared by multiplying I and I. What about multiplying 2 and I and 6? You still need a minute.
This is not 2 plus I. This is 2i. This is 7i. If you were doing 3x plus 5 and 2x minus 1, when you do this, what do you get? No mystery, right? But now because we use the letter I, it's all a mess. The new iPhone has you all bugged out because you can't wait to get it. You deserve the best. Tell your mom, Mr. Lockery said I deserve the best. I should get a new iPhone. Then you got 2 weeks. I times I is I squared. 2i times 7i, 14i squared. Negative. Okay? What are we doing? Oh, I unshook them. All right. Now, let's talk about factoring. Let's talk about factoring real quick. If this was a squared minus b squared, what would you call it? If it said a squared minus b squared, what would you call it? A difference of 2 squares. And if you can't recognize that, again, I cannot express to you in better terms that if you don't know how to factor and don't know the terminology, you're in deep doggy doo-doo. This is not a difference of 2 squares. It is a sum of the squares. And up to this point, when you had x squared plus 100, what did you tell me when I asked you to factor it? X squared plus 100, up to this point, if I asked you to factor that, okay, so again, the preparation for this class is getting to be pretty thin. X squared plus a 144, for example, you would say that is not factorable. Yeah, except I just got 10 different responses on how to factor it. X squared plus 100, x squared plus 144. Can't factor it because it's a sum of the squares. But now if we allow you to go to complex numbers, it will factor like a difference of 2 squares where the second terms have the imaginary unit. X squared plus 144 will be x plus 12i and x minus 12i. What do those look an awful lot like from yesterday? What do these look an awful lot like from what we did yesterday? Not from what we did yesterday. In yesterday's class, this looks an awful lot like something we did in class yesterday. Conjugates. What kind of numbers are we talking about here? So what kind of numbers are these that we're looking at? Complex. So what are we going to call these two things? Boy. Complex conjugates.
What other imaginary numbers are there? Is there anything besides I?
Well, I covers them all, doesn't it?
Oh, it does.
Something times I, A plus BI, covers every imaginary number there could possibly be. So they're all taken care of in that form of a complex number, A plus BI. So x squared minus 9, how does that factor? How many of you think x equals 3 and negative 3 for that? Yes, some of you do. Why doesn't it? I didn't forget anything. This is how it factors. Some of you will then do this. Plus x equals negative 3 here and positive 3 here. Why can't you do that? It's not an equation. This isn't x squared minus 9 equals 0. This is just x squared minus 9. It's an expression. We're factoring it. This is an expression. How's it factor? And why is it with the eyes on this one and not the one above? The plus. Sum of two squares. Of course. That's a difference of two squares. A plus B, A minus B. Step number 2 to factoring. It's online.
Oh, Lord.
The Lord has nothing to do with this. How's it factor? Come on, don't overthink it.
Plus 7.
Plus
17
X plus.
17.
Yes, you can. Complex numbers, come on. Stop thinking it's too hard.
17.
X plus what?
79.
It's not 17i.
Just
Root 17. I times x minus root 17i. Just gives you the opportunity to factor it, which we would normally say, forget it. We're not doing that. But we can handle radicals. We can handle complex numbers now. It's okay. If you don't study, and some of you still haven't studied one time in chapter 4, you are in for it. I am telling you, you need to get these details in here. And when you think you're going to do it next Wednesday night and get it all together, it just doesn't work. Okay? It doesn't work. Absolutely, because root 8 has to be simplified to 2 root 2. That's a great call. If you can simplify the radical, you've got to do that. Okay, the last thing I want to talk about very quickly is the complex plane, which it's really easy to plot on the complex plane. You end up with numbers that are complex. Here they are. So what we've done is we have the regular coordinate plane, but we call the horizontal axis the real axis. And we call the vertical axis the imaginary axis. Horizontal is real, vertical is imaginary. So if we view letter B here, 4 plus 2i, which part is real? 4, which is imaginary? 2i. So from the origin, we go right 4 on the real axis and up 2, and that's how you plot the point 4 plus 2i. Yeah, it's called the imaginary plane. So we have an imaginary axis and a real axis. It has to be labeled like that. Negative 4i. How do you write it as a complex number? How would you write negative 4i as a true complex number? 0 minus 4i. Real part? 0. Imaginary? 4. Minus 4i. So here's 0 on the real, down 4 on the imaginary. That's negative 4i. Negative 1 plus 3i. Real part, negative 1. Imaginary part, 3i. Negative 1 plus 3i. And finally, 2 minus 2i, write 2 down 2, 2 minus 2i. You have an imaginary number there. This, I can tell you for sure, is a STAR test question. We'll talk more about that towards December. Okay. There is 1 or 2 other details from this section, like absolute value of imaginary numbers.